Hello everyone, this is Usa. Welcome to a quick tutorial on the 2D structural analysis tool, project that I work on under the supervision of my dean, Mr. Mengleang. More on that over here. But basically, this website is a structural analysis tool that allow you to put together a structure using various different structural components available over here, and then analyze it to find the reaction force and plot the stress resultant, the normal shear moment, as well as the deflection diagram. So let's get started. First, we have this tab here on the right, which is the setting tab, where you can adjust the setting, such as the grid size, the mesh size, and the unit system. And then in the center here, we have the grid, which is where the structural component is going to be displayed when we are input once input. Then finally we have this input tab over here, which we can input different structural components. So let's start by adding a member. We can do that by first specifying the beginning coordinate. I'm going to go with 1 1, and then next we're going to specify the direction the member will go from the beginning coordinate. I'm going to go with 2 to the right, and then 3 meter upward, and then press add. And then we can see the member appear here in the grid, and also here in the table where the information about the member is displayed, like the length, and also there's this edit button which you can use to edit the member, as well as this button which you can use to delete the member. Next, I'm going to add another member, but instead this time I'm going to use this joint coordinate here. I'm going to select joint B over here, and then go 3 meter to the right from that joint B. Press add. Next, we can add support. I'm going to add fixed support to joint A, and then for joint C, I'm going to go with a pin support. Then we can add some load. I'm going to add a point load to member 1 with respect to the local coordinate system. I'm going to go with 1.8 meter from the beginning coordinate, from the beginning joint. So basically it's in the center of this member. And for the load vector, I'm going to go with 100 kilonewton, but downwards. So add a negative sign over here, and then press add. Next, I'm going to add the linearly distributed load on this member 2 over here. With respect to the global coordinate system, I'm going to select the vertical load. I'm going to leave this B so that the load will span across the entire member. And then for the load vector, I'm going to go with 100 kilonewton per meter downward to 150 kilonewton per meter downward. Then you can see here, if you hover over this knot over here, the value of the load that we just add. And now what we essentially have is a structural analysis problem. We have a member, a support, and a load. There's also some other structural components like the hinge and the external effect, which I'm not going to cover in this quick tutorial, but feel free to explore by yourself. Anyway, we can go to the solution tab over here, which solve the structural analysis problem for us, and then we can click on this reaction force and press play to display the reaction force, which we can hover over the end of the arrow here to see the value, as well as the normal force diagram, which we can display over here, the shear diagram, the bending moment diagram, again, but in reverse orientation. And then finally we have the deformation or deflection diagram. Last but not least, we have this mesh size over here, which we can adjust to change the number of element on this member, and as well as the number of node. So let's change it to 0.5, then press save option over here. We can see the number of finite element have jumped or doubled from 7 to 14, and the our diagram over here have become a little bit more smoother. And feel free to uh, change or adjust this size according to your need. However, there's the minimum limit to the what this value, as well as a maximum limit to the number of finite elements. And with that, this is the end of this quick tutorial. You can access the structural analysis tools via this link over here, permalearn.xyz. Thank you for watching this video.